This week's experiment, we're going to be doing titration, and as I mentioned in the lab, we use a device called the burette. So this is the burette. I'll be showing you an up-close view of the burette so you can get an idea of what the measurements look like. It has a couple of different components on the burette. There's the barrel, that's the long, narrow part, and then there's the tip, and then there's a stopcock, and this is the valve that keeps liquid from leaking out of it. So when you fill it up, you're going to turn it sideways like this, okay? And you'll fill the liquid to the top. And now on the markings on the side, at the very top, it says 0, and at the very bottom, this one says 50. So what'll happen is you'll put liquid in here, and as you dispense it out, when you stop, let's say it reads 17.00. That means 17 milliliters, 17.00 milliliters have dispensed into whatever you've been dispensing it into. Typically, that's an Erlenmeyer flask. And that's how we're going to figure out what the concentration or the amount of substance is inside the flask, or we alternatively can use that to determine the concentration of the material that's inside the burette. Okay, so here's the setup. There's the Erlenmeyer flask. It contains a sample of acid in it, and that's what we'll be titrating. And then in the burette, I have sodium hydroxide, and I filled it up. And before we go into details on the measurement, you can see the liquid level is just right here for now. But before we go into the details of the experiment, I wanted to show you what it looks like when you do a titration so you know when to stop adding the sodium hydroxide. You can see I have an automatic stirrer in there, and I have some lights and a piece of white paper to help you be able to see a color change that happens when you're supposed to stop. Indicator looks like when you put it in. So I'm going to put the indicator in. You really only need a couple of drops. And so I'm going to count out 1, 2 drops. And you'll notice nothing really happens yet. But what I'll be doing is I'll be adding the sodium hydroxide, and we're not going to do any measurements yet. I just want you to see what it looks like when this goes in. I'm going to turn the stir rate up just a little bit. Normally we do this by hand, but for the video, I thought I'd just show you real quick. I'm going to zoom in here. I don't know if you can see at the very top, it's starting to turn a little bit pink. That pink color is an indication that there's an excess of sodium hydroxide. Now when that color is permanent, and maybe that's even a little bit too dark, but when that color is permanent, you'll know you need to stop adding the sodium hydroxide to the solution. Now you notice how it's faded a little bit. That's because it's mixed in finally. And the last thing you should be doing too is washing down the sides of the container using a wash bottle to squirt some water in there to wash it on down. In part 1 of the experiment, we'll be determining the concentration of the sodium hydroxide. And we'll be doing that by titrating potassium hydrogen phthalate. We need about 1/2 gram, and this is for the first trial of the experiment. So we'll record that as our mass of KHP, and you can use that number in the calculation. For trial 1. I'll be adding it into the Erlenmeyer flask along with 25 mils of water. to make sure it all gets off the paper. And then I'll stick it on the stirrer. And then I'll go ahead and I'll add the water. And then we'll wait for it to dissolve. And we'll also add our indicator phenolphthalein. So this is the initial burette reading. The top value says 4, the bottom value says 5. So when you read this, you need to zoom in and read from the top to the bottom. So this one looks like it's about 4 point and then 7.2. Now you notice I have a piece of red tape held below the meniscus in the back, and that highlights the meniscus in red by reflecting the red color, and that helps you make the measurement. So this is 4.72 milliliters for my initial volume. Okay, so now I'll be titrating this solution. It's dissolved and everything's there. And I'm just gonna run this down quickly. The burette tip should be just inside the Erlenmeyer flask top. And when I start to see a permanent pink, I'll slow down. But for now, it's just all very lightly pink. You can see that pink color as the sodium hydroxide goes in. As you get very close, that pink color persists longer and longer. The technique I'm using is to take the stopcock and twist it like that. And that gives a small amount of solution. If done correctly, it gives about the volume of half a drop. Please notice the pink staying. It's very faint, but you can see it. That's where you want to be, and you give it 30 seconds, and if it stays, you'll stop and record the volume at that point. So here's the next reading. This is between 27 and 28, and it's below halfway, so it looks like it's right around 27.7. You notice it's just below, but 7.1 or so. You might say 7.0. So that would be 21.70. Now, in the future portions of this video, I'll be recording these values on the video, but you need to make the readings yourself. So you'll pause the video at each point and record the numbers you're seeing. Be sure you record the correct number of significant figures when you do this, at least to the hundredths place. So 27.7 would be the tenth, so go to the next place. 70 would be to the hundredths place. This is trial 2 of KHP. This is trial 3 for KHP. titration 2. Endpoint volume titration 2. KHP titration number 3, initial volume. KHP titration number 3, endpoint volume. In the second part of the experiment, we're going to be determining the concentration of the sulfuric acid inside this bottle. So this is your unknown. We'll be doing it 3 times, so 3 trials. And so what I'll be showing you is the measurement, initial sulfuric acid volume, or initial sodium hydroxide volume for the sulfuric acid titration 1, and then also the final one. And I'll be doing that for each trial. The volume that we're going to be adding of the sulfuric acid is 10.00 milliliters. So I'll add exactly that amount to each one. Initial volume sulfuric acid titration, number 1. Trial 1, final titration volume for sulfuric acid. Sulfuric acid, trial 2, initial volume. Trial 2, sulfuric acid, endpoint volume. Third trial, sulfuric acid, initial burette volume. Sulfuric acid, trial 3, endpoint.